Okay, hi guys. Welcome to the video for Unit 11. We're going to be doing a review for acids and bases. Let's get right into it. There's 52 questions in total. Number 1, compare the number of moles of hydronium ions to the number of moles of hydroxide ions in the titration mixture when the hydrochloric acid is exactly neutralized by the sodium hydroxide. So let me just get my marker. Hold on. So they're saying that we are neutralized. When we are at neutralization, the numbers of hydronium and the numbers of hydroxide ions are the same, and that is why it's considered neutral. So we can just say equal or same. It literally doesn't need to be any more than that. That is perfectly fine. Next, they're asking us to determine the molarity of the hydrochloric acid sample based on the titration data. So there are two formulas on table T where molarity is involved. So we have the molarity formula, and then we have the titration formula. The titration formula also involves concentration or molarity. So we're going to use the titration one. So if you go to table T, it's MA times VA equals MB times VB. The concentration of the acid times the volume of the acid equals the concentration of the base times the volume of the base. So we're just going to plug everything in. So here I can see that we have 16 milliliters of NaOH. So we're talking about the base here, and that's the volume. So that's right here. And the molarity is 0.18. So that's right here. And then we are given the volume. I know it's volume because it's milliliters. We're given the volume of the hydrochloric acid. So that's right here. So that's 24. And what we're looking for is the molarity of the acid. That's M sub A. So what we're going to do is we are going to simplify here. We're going to divide everything by 24. So hold on, let me just grab my calculator. So 16 times 0.18, that gives us 2.88 equals 24x. Divide by 24 on both sides, and we should get that x is 0.12. And we were really solving for M sub A, which is the molarity of the acid. So the unit should also be capital M for molarity. All right. Number 3, which substance can be classified as an Arrhenius acid? So here, again, Arrhenius acids, when they are put into aqueous solution, they break up and they give off hydrogen ion or hydronium ion. So this is going to break up into Li plus and H minus. This one is ionic. This is not it. Again, it has to be H plus. This is K plus, OH negative. This is a base. This is hydrofluoric acid. This will break up into H plus and F minus. So this is what we're looking for. So we're going to want to go with choice C. This is going to break up into K plus and F minus, another ionic or salt like A. So A and D are both salts. B is a base, and C would be our acid because it gives off that H plus in solution. All right, number 4, given the balance equation representing a reaction, the water molecule acts as a base because it does what? So this is looking at the Brønsted-Lowry definition of a base. And according to Brønsted-Lowry, bases are bases because they accept protons. So if anything is acting as a base, according to Brønsted-Lowry, it's because it is accepting H. And you can also see here that we're saying that the water is acting as a base. And you can also see that this is what it is most related to on the other side. So this is its conjugate acid. And you can see that the only way that H2O could have become H3O plus is by gaining or accepting an H plus. So we're going to want to go with choice B. Okay, number 5, what is the pH of a 0.001 molar HNO3 solution? So we need that negative log, the concentration. Oops, sorry. Struggling with the pen here. So we just plug this into our calculator and we should get a pH of 3. So this is an acidic solution. And also this is an acid, so it should be something below 7. All right. Next, number 6, when the concentration of hydrogen ions in a solution is decreased by a factor of 10, the pH of the solution, we're going to want to go with B. So note that they're saying that the amount of hydrogen ion decreases. This means that we're becoming more basic. So our pH should be going up. Again, it's 1 or 0, sorry, 0, 7, 14. The bases are here, the acids are here, and the neutral things are right here. So if we are decreasing how much hydrogen ions, it means we're going up. We're getting closer to becoming a base. So our pH value should change or increase by 1. Number 7, in a titration, we have all of this information about hydrochloric acid and potassium hydroxide, and we want to know what is the concentration of the base. So again, we're going to use that M sub A times V sub A equals M sub B times V sub B. And when I say sub, I mean subscript. Okay, so we're just going to plug everything in. So I see here, we're talking about hydrochloric acid, so that's my acid. So my volume is 10. My concentration is 0.075. The molarity of the base, that's what we don't know because they're asking for the concentration. So that's X, but the volume of our base, we do know, that's 30. So we plug everything in. We're going to simplify here. That's 0.75 equals 30X. Divide both sides by 30, and we should get 0.0250 molar. So choice A. All right. Number 8. We're given this reaction, and then according to one acid-base theory, the reactant that donates an H plus in the forward reaction is, so they're talking about Brønsted-Lowry here. So again, water can act as an acid or a base. Here it is acting with something that is known as a base. Ammonia is a base. So the water is going to be acting as the acid, okay? And also the way that we can tell is, I know that, I'm going to color code this here. Let me clear this. So I know that this belongs with this, and this belongs with this. And I can see what happened to the water. The water lost a hydrogen ion. So things that lose hydrogen ions are acids. So this would definitely be our acid. Choice D. Okay, number 9, the pH of a solution is 7. When acid is added to the solution, the hydronium concentration becomes 100 times greater. What is the pH of the new solution? Now, in between every singular pH value unit, there is a change of hydronium ions by 10-fold or 10 times. Now, we are starting at 7. So it goes from 0 to 7 to 14. Here are our acids, here are our bases, and here are our neutral things. So we're here at 7. Now we add acid, so we're clearly going to go down. Our pH is going to go down. And they're saying that it's going down 10 times. So 10 times means that we have changed our pH value by 2. So from pH 7 to pH 6, it means that 6 has 10 times more hydrogen or hydronium ions than 7 does. If we go another value, this is another 10 times. And so together it is 100 times altogether. So we're going to end up with a pH of 5. Number 10, which substance is an electrolyte? Electrolytes are anything that are acids, bases, and salts. This is sugar, that's ionic. This is the main constituent of sand. This is a molecular solid. You can find this in our notes from chapter 7 or unit 7. By the way, for this exam, I definitely recommend taking a look at unit 7 and unit 8. There is a lot of that information kind of, all throughout this unit as well. B, carbon tetrachloride. This is a non-polar liquid. This is molecular, not an electrolyte. This is our only electrolyte here. This is sulfuric acid. Again, it is an acid. Acids are electrolytes because they dissociate. Anything that dissociates will have ions or charge, mobile charge running through the solution, which allows it to conduct an electric current. Okay, number 11, what color is phenolphthalein in a solution that has a pH of 9? So let's clear this, and we are going to go over to our reference table, table M. That's where we have all the indicators listed. And so they're saying that we have phenolphthalein, and it is in a solution with a pH of 9. So if it is 9 or higher, 9 is the second number here. So it corresponds to the second color that you see here. So phenolphthalein is a good indicator for bases. It turns pink when it is in contact with bases. However, it has no effect on acids. It is colorless in acids. It will just look like water. So our answer here should be pink. Where were we? Sorry. Okay. So yes, pink. Okay. Last one on this page, which compound is an Arrhenius base? Arrhenius bases always give off hydroxide ions, so you have to look for the thing with hydroxide. It's definitely not A, that's carbon dioxide. C doesn't have anything like that. It's going to break up into calcium and sulfate, so it's not that. It's not B, although a lot of people might think that it is. B is an alcohol. That is a hydroxyl group, okay? I guess the hint that I would give is if you see OH at the end of something, but you see carbons and hydrogens in it, it's going to be organic, and that's going to make it an alcohol rather than a base. This is calcium hydroxide. This is our base. So choice D. Okay, on to the next page. By the way, I'm trying to go a little bit faster than normal. So if I am going too fast, this is on YouTube, so you can just slow down the video, or you can rewatch it a few times. Okay. 13, according to Arrhenius theory, which list of compounds includes only bases? So for this one, we are going to want to go with, let me see my options. It's not A. Not A, because this is an alcohol. Not B. This is also an alcohol. This one is ethylene glycol. You might want to memorize this one. This is an alcohol with two hydroxyl groups. Here, C, this is potassium hydroxide, sodium hydroxide, and lithium hydroxide. All of these are going to break up, dissociate, and give off hydroxide ion into solution. But finally, let's also just take a look at D. The thing that's wrong with D is this one. This is an acid. Although it has OH at the end, that is not the full group. The functional group here is the carboxyl group right here. This is an organic acid specifically. It's acetic acid, otherwise known as ethanoic acid. It's an organic acid. Okay, number 14. According to one acid-base theory, which pair are the H plus donors or hydrogen donors? So this is also talking about the Brønsted-Lowry theory. So, okay. So let's see. Okay, so basically, what they're asking for, the things that are going to donate hydrogen ion are going to be acids. So we need to look for the thing that is an acid and the thing that is a conjugate acid. So I'm going to label everything. Here, I see that water, H2O, becomes OH on the other side. In order for water to do that, it had to lose a hydrogen ion. So this is my acid. Here is my acid. That means that this is my base. And if this became this, that means that hydroxide is my conjugate base. And if ammonia became ammonium by gaining, this is my conjugate acid. So the two things that qualify as acids are water and ammonium. So we would want to go with choice B. Okay. Number 15, according to an alternative theory, whenever they say alternative theory, they're usually talking about Brønsted-Lowry again. So according to an alternative theory, water is considered to be a base when it doesn't even matter what substance they're talking about. If they're saying something is going to be considered a base under Brønsted-Lowry, it means that it is accepting a proton. So this is A. Again, when we say proton, we're also talking about H+, because hydrogen ion is essentially a proton. Because if you think about it, hydrogen on its own has one valence electron. It's got one proton and one electron. However, when it loses this electron, it gains a positive charge, and it also did so by getting rid of that electron. And hydrogen doesn't have any neutrons. So it literally at this point is just a proton. So we can call hydrogen ion or refer to it as a proton as well. Okay. Number 16, which of the following liquids is the best conductor of electricity? Let me move the page a little bit. Okay. So we need to look for something that is an electrolyte. Again, electrolytes are acids, bases, and salts. And also, they have to be soluble salts. Insoluble salts are really not good electrolytes because they don't dissociate, so they don't really give off that much charge. All right, so it's definitely not A. This is molecular. C could work because this is a base. It's going to be C. It's not D because water, when it's pure, and it's like this, when it's written like this, it's just water. Pure water doesn't have any ions dissolved in it, so it doesn't conduct electricity. B is an alcohol. Alcohols do not conduct electricity either. Again, it has to be an acid, a base, or salt. 17, which aqueous solution is the best conductor of an electrical current? So where all of the options are all sodium nitrate, which is a very soluble salt. So all of these will conduct electricity. However, what we want to look at is the concentration. The more sodium nitrate you have, or the higher the concentration is, it means that there is going to be a lot more ions. So all you have to do here is just look for the one with the highest concentration, which would be A, 0.2 molar. 18. When tested, a solution turns red litmus to blue. This indicates that the solution contains more. We are going to want to go with choice D. So a trick here is that if you turn litmus blue, it's a base, so they both start with B. Blue, base. And so if it is a base, it should definitely have more hydroxide than it does have hydronium. If it has more hydronium, it's an acid. And again, when these things are equal in number, then it's neutral, like water. All right. 19. Another titration problem. Which volume of 0.1 molar sodium hydroxide exactly neutralizes 15 milliliters of a 0.2 molar HNO3 aqueous solution? So whenever they're talking about neutralization, they're giving you volumes and they're giving you molarity, they're talking about titration. So again, MA, VA equals MB times VB. So the way we're going to plug this in is our acid. We have all the information for our acid. There's 15 milliliters. It's 0.2 molar. Molarity of our base we know is 0.1, but we don't know the volume. So we solve for X as we did in the other examples, and we should end up with B, 30 ml. Okay. Number 20, water containing dissolved electrolyte conducts electricity because the solution contains mobile. So we are going to want to go with ions. Okay. Something is dissolved. Things or ionic compounds dissolve by breaking apart or dissociating into their ions. And so those things that have charge, these ions, as they flow through the solution, they allow the water to conduct an electric current or electricity. Number 21, which pair represents an acid and its conjugate base? So again, I'm going to color code. I know this belongs with this, and this belongs with this. And also notice that the arrow is double-headed, so it can go either way. So all you really have to do for these sorts of questions is just look for the pairs. Do they give you this pair as an option, or are they giving you this pair as an option? And upon looking at our choices, A is not a match, B is not a match. However, C is our match. So we're going to want to go with C. D doesn't match up. Okay. That is the trick for those sorts of questions. Number 22, which chemical equation represents the reaction of an Arrhenius acid and an Arrhenius base? So this is describing a neutralization reaction. Neutralization reaction always gives rise to two products, water and some sort of salt, some ionic compound that is not an acid or a base. So we need to look for the ones that have water and salt as our products. If we are looking at A, I do see water, and this is sodium acetate. This is an ionic compound. So we are going to want to go with choice A. However, let's look at the other ones. Choice B, we have, this is propane in contact with oxygen gas. This is combustion. B, or choice C, sorry. This is a double replacement reaction. Barium and sodium are swapping places. Our two metals are swapping places. And D, we have zinc booting out the hydrogen. The hydrogen is all by itself over here. and we end up with a different salt. This is a single replacement reaction, but as we recently learned, it can also be classified as something else. This can also be called an acid-metal reaction. This is the other common reaction that we'll see with acids. Okay. Number 23, a conjugate acid-base pair is, so again, we're gonna color code our pairs. So ammonia becomes ammonium by gaining. So ammonia is our base here. And water becomes hydroxide by losing. So water is our acid. Ammonia is our base. So we just have to look for the things that are paired up. They're always going to usually give you just one option. So NH3 and OH, those are not pairs. The ones that are color coded the same color are the pairs. H2O and OH, there we go. There is our pair. This doesn't match, this doesn't match. Those are not pairs either. All right, 24, in a solution, litmus is blue. The pH of the solution could be, again, blue means it is a base. Again, if you look at our scale, it goes from 0 to 7 to 14. Bases are here, acids are here, neutrals here. So if it is blue, it's a base. Bases are going to have something above 7 to 14. So our only option is A, pH of 10. All the others are acidic. Moving right along. Number 25, when the pH of an aqueous solution is changed from 1 to 2, the concentration of hydronium ions in the solution is what? Again, here are acid bases. So if we go from 1 to 2, it means we're getting closer to becoming a base. This means if we are becoming less acidic, it means we do not have as much hydronium as we did. So we're definitely decreasing how much we have. And if we are changing from pH value of 1 to 2, that is a difference of 1 pH value. And the difference in hydronium concentration from 1 pH value to the next one is a factor of 10. Again, we always increase or decrease by 10-fold in between each pH value, depending on which way you're going. 26, based on the Arrhenius theory, when potassium hydroxide dissolves in water, the only negative ion in the solution is, this breaks up into potassium and hydroxide. So the only one is hydroxide. And it has a negative charge, negative one. You can find this in table E. Please be comfortable and please be familiar with the polyatomics. That is important. Next, which 0.1 molar solution has a pH greater than 7? If it's greater than 7, it's going to be a base. So you just have to pick out the base. A is our base, that is potassium hydroxide, like we just determined right over here. C is acetic acid. This is an acid. This is sugar. And this is salt. Okay. 28. What are the relative ion concentrations in an acid solution? So if something is more acidic, it is acidic because it has more H+ or more hydronium than it does have hydroxide. Again, acids have lots of H+. Bases have lots of OH- or hydroxide. And neutral substances have equal amounts. Okay. Number 29, the pH of a 0.1 molar acetic acid solution is what? They're not asking for specifics. However, this is an acid, so it should be below 7. So it's not less than 1. Not equal to 7, that would make neutral. It's not greater than 7, that would be a base. It should be greater than 1, but less than 7. And the way that you can also check this is by plugging it in, negative log of 0.1. If you plug this into the calculator, we can go do that now together. So if I type in, negative log of, let me do it here. Negative log 0.1, and we get 1. So the pH is 1, but it's not less than 1. Again, that's why choice A wouldn't have worked. So we would want to go with choice C. Okay, 30. All right, so we have this whole reaction, and then we have NO2 minus, AQ acts as what according to this reaction? So again, I'm going to color code everything, so that belongs with that. What happened to this thing? Well, in order for this to become this had to gain. H plus. And according to Brønsted-Lowry, if something gains a proton or gains a hydrogen ion, it is a base. So this is an alternative theory base. And again, by alternative theory, they mean Brønsted-Lowry. If this was an Arrhenius base, it would mean that it gives off OH, but NO2 minus is not going to do that. (31) Which substance always forms when an Arrhenius acid reacts with an Arrhenius base? This is a neutralization reaction. Our two reactions are always water and salt. However, I see that there is no salt here, but I do have water, so that is always one of my products. This is carbon dioxide, this is methanol, and this is just hydrogen gas. Next, number 32. So we are given what is the molarity of a 0.5 liter of an aqueous solution that contains 0.2 moles of NaOH. So this is actually back from our other unit, unit 10. This is a molarity question, but just to keep you sharp. Again, molarity, this is on the back of table T, equals moles of your solute in how many liters of solution. So we have 0.2 moles dissolved in 0.5 liters. When we do this, we should get 0.4 molar. And they give you the gram formula mass, but you don't need it in this case. If they had given you this information in grams, then yes, you would have needed this, but in this case, we don't. 33, as more solid sodium chloride is dissolved in a dilute unsaturated sodium chloride solution, the conductivity of the solution does what? So if you are dissolving salt in water into an unsaturated solution, again, unsaturated means that this given amount of water can still dissolve more solute. So if we dissolve more, obviously the concentration of ions is going to go up. So it's not B and it's not C. The conductivity is also going to go up if you have more ions. If you have more ions, there is more charge, mobile charge to conduct the electricity. So we're going to want to go with choice D. We increase the ion concentration, you also increase the conductivity. 34. Which two compounds are electrolytes? Again, electrolytes are acids, bases, or salts. I can see that A is not it. This is an alkane, that's an organic molecule. Again, all organic molecules are non-electrolytes except for organic acids. B is not it. We have an acid here, that's acetic acid, that's good, but this is an alcohol, so no good. C is good because this is a base and this is an acid. So we're gonna wanna go with choice C. Let's just look at why D doesn't work as well. This is an alcohol, no good. And this is also an alkane, that's pentane. 35, which equation represents the neutralization reaction? Again, look for an Arrhenius acid and base on the reactant side and salt and water on the product side. Not A, that's combustion. B, this is good. We have calcium hydroxide, that's an Arrhenius base. Sulfuric acid, that's an Arrhenius acid. We end up with calcium sulfate, that's salt, and there is our water. So definitely choice B. But let's look at the others. Choice D is not it because we start off with one reactant and end up with two on the other side. So this is considered decomposition. And D, we have two ionic compounds on this side, two ionic compounds on the other side. And what happened? Our metals swapped places. This is double replacement. 36, which indicator would best distinguish between a solution with a pH of 3.5 and a solution with a pH of 5.5? So we're going to need table M for this. Let me just move this out of the way. Okay, so they were saying, again, that it is going to distinguish between a pH of 3.5 and a solution with a pH of 5.5. So our best option would be Brome-Cressyl green. In a solution below 3.8 Brome-Cressyl green, when you add it into your solution, it will appear yellow. If the solution has a pH 5.4 or above, like we do here, it would appear blue. Again, the first number that you see corresponds to the first color that you see. Okay, so for that one, we are going to want to go with choice B, Brome-Cressyl green. Number 37, what is the pH of a 0.01 molar solution of HNO3? I feel like I already did this. Maybe, perhaps, or something very similar to this. Anyways, they're giving us the molarity. So we use negative log of the concentration of our hydrogen ion. We plug this into your calculator and we should get that we have a pH of 2. So this is rather acidic. Next, number 38. Okay. All right, so they give us all this information. And here is important information that they give us. A hydrochloric acid solution with a pH of value of 2 is used to determine the molarity of potassium hydroxide. They want us to determine the pH value of a solution that is 10 times less acidic than HCl. So again, 0, 7, 14. Acids, bases. If we are starting at a pH of 2 and we are becoming less acidic, it means that we're getting closer to 7 or closer to 14, becoming more basic. So our pH value is going to go up. And they're also telling us it's 10 times. In between every single pH value from 1 to 2, 2 to 3, 3 to 4, in between each value, there is a 10 times change in hydronium ion. So if it's 10 times less acidic, we're going to go from 2 to 3. So the pH is going to be 3. 39. A student completes a titration by adding 12 ml of sodium hydroxide of unknown concentration to 16 ml of 0.15 molar hydrochloric acid. What is the molar concentration? Molar concentration is another way to say molarity of the sodium hydroxide. So again, another titration. So let me just scroll a little bit. Okay. So again, we need, let me write it here, MA, VA, MB, VB. So we don't know the molar concentration of the acid. So this is X. The volume of the base is 12 ml. So that's 12. And then we have this information about the acid. So 0.15 molar. And sorry, this is so small, 16 ml. When we solve for everything, solving for X, we should end up with 0.2 molar. 40. What is the conjugate acid of HPO4 2-? So if we're asking for the conjugate acid of this thing, it means that this is the base. And bases, according to Brønsted-Lowry, accept protons. So they accept H+. So what you have to do is add another H+ to this. So then if we add another one, we'd have 2 hydrogens. We still have our PO4. And we have a charge of -2. But if you're adding a positive to this, it's going to go up to just -1. So we're going to want to go with choice D. Next, which compounds can be classified as electrolytes? Not alkynes, not alcohols. Organic acids work. Saturated hydrocarbons do not. Again, the only organic compounds or class of organic compounds that are considered electrolytes are the acids. All of the others, alkanes, alkenes, alkynes, alcohols, ketones, aldehydes, ethers, esters, none of those things are considered electrolytes. They do not conduct electricity because they do not dissociate into ions when you put them in water. Next, which term describes an acid according to one acid-base theory? So an acid is going to be not H2, it's H+. We're always talking about H+ or hydrogen ion when we're talking about acids and bases. Acids always give off or donate. So we're going to want to go with choice D. Number 43, another question with pH value changes. When the pH of a solution is changed from 4 to 3, so we're going from 4 down to 3. That means we're getting closer to 0. It means we're becoming more acidic. If you are becoming more acidic, it means you have more hydronium. So we're not decreasing, we're increasing, but we are only going from pH 4 to pH 3. That's 1 pH value. This is always a change of 10 times. So it's a factor of 10, not 100. To change something by a factor of 100, it would have to be a difference of 2 pH values. So it would have to be from like 4 to 2. Next, the conjugate base of HSO3- ion is what? If we're looking for the conjugate base, that means that this is the acid. Acids always donate hydrogen ion. So we have to get rid of that H. So we're getting rid of H+. So not only are we losing the H, but we're also getting rid of that positive charge. So we're losing positive charge. We're going to be even more negative now. So it's going to be -2. So we're going to want to go with choice D. Okay. Number 45, which process uses a volume of solution of known concentration to determine the concentration of another solution? This is a titration. 46, phenolphthalein has a pink color in a solution, which has a pH of what? We went over this before. This is only pink in basic solution. So 11 is the only basic pH here. 7 is neutral, 5 and 1 are both acids. 47, which type of reaction occurs when an areneous acid reacts with an areneous base to form a salt and water? This is a neutralization reaction. Next, the compound HNO3 can be described as what? So this is definitely an acid because I see that H plus here. It's going to break up into H plus and NO3 minus. So it's not a base. Bases give off OH negative or hydroxide. And acids, bases, and salts are all electrolytes. So we're definitely going to want to go with this. If it's an acid, it's an electrolyte. Again, because they're breaking up into these ions. So we have mobile charge running through our solution. Okay. Where is 49? Oh, okay. I just went too far. Okay. Number 49, the hydronium concentration, when they put, okay, I actually did not say this in class, my apologies. When they put a substance like this in brackets, the brackets means that they're talking about the concentration of this thing. So they're saying that the concentration of hydronium is 1 times 10 to the negative 8 molar. So we want to know what is the solution of this thing. Okay, so if you plug in negative log of 1 times 10 to the negative 8, also if you're using scientific notation in a calculator, please make sure that you use parentheses because some calculators are, very fragile. That's not the word, but you know what I mean. Okay, they're very sensitive, however you want to put it. We put this in and we get 8, which is basic. Again, anything above 7, basic. Okay, number 50. We are given this chart and they give you all this information. And then at the end of the day, they're just asking you to identify the ion released by the compound dissolved in sample 4, so here, that allows the compound to be classified as an areneous base. We didn't even need to know that this was it, because if something is being classified as an areneous base, it means that it is an areneous base because it is giving off this. So you could say this, you could put the name. I think either should be fine. Okay. 51, which equation represents neutralization? Again, we're looking for an areneous acid and areneous base on the reactant side and salt and water on the product side. Not A, this is synthesis. 2, we have potassium hydroxide, base, and sulfuric acid, acid. And then we end up with salt and water. So we're going to want to go with choice B, but let's look at the others. Choice C is also like choice A, that is synthesis. And choice D, we have 2 ionic compounds switching their metals. This is double replacement. And here we are, 52. So they give us all this information and then they're asking, explain it in terms of ions. So the word ions must be in your response. Okay. So for 52, what we can say, we can keep it very simple. We can say that HCl aqueous has, oops, sorry, not watching where I'm writing, has ions in water, which are mobile. So all we really need to know is that it can conduct electric current because it has mobile ions. That's all you need to say. As simple as that. Again, please do not elaborate too much. Like, don't keep going on and on for short response. Keep it as simple and as brief as possible. That is usually the best way to go. Anyways, I really hope that this was helpful. Okay. Good luck studying, and I'll see you guys back for the next video. Bye, everybody.